So we have a beautiful exponential equation. Okay, now so we have 6 exponent x plus 9 exponent x equals 2 exponent 2x plus 1. Okay, now let's apply the first law of indices at the right side of the equation. Okay, so the first law states that a exponent m plus c should give us a exponent m times a exponent c. Okay, so when the bases are the same and the sign between them is multiplication, we add the exponents. Okay, so our equation becomes 6 exponent x plus 9 exponent x equals 2 exponent 2x plus 2 exponent 1. All right, now our equation becomes 6 exponent x plus 9 exponent x equals, now we can write 2 exponent 2x as 2 exponent 2 times x. Okay, and then here we have 2 exponent 1 being 2. All right, now let's further. Okay, now we are going to apply the power of a product law of indices here. Okay, so if you have a exponent m times c, okay, this is equal to a exponent m multiplying the exponent c. Okay, so our equation becomes 6 exponent x plus 9 exponent x, okay, equals 2 exponent 2 in a bracket, and then we have x here times 2. All right, so our equation becomes 6 exponent x plus 9 exponent x equals, now 2 exponent 2 is 4. Okay, so we have 4 exponent x times 2. All right, so our equation becomes 6 exponent x plus 9 exponent x equals 4 exponent x times 2. All right, now let's divide all the terms of the equation by 4 exponent x. Okay, so here by 4 exponent x, here by 4 exponent x. Okay, now we are going to have 6 exponent x over 4 exponent x plus 9 exponent x over 4 exponent x equal, now anything over itself is 1. So 4 exponent x over 4 exponent x is 1. So we have 1 times 2. All right, so we are going to have 6 exponent x over 4 exponent x, okay, plus 9 exponent x over 4 exponent x equals 2. All right, now let's apply the power of a quotient law of indices. Okay, so you can say the power of a quotient law or the power of a quotient rule. Okay, so if you have a exponent b over c exponent b, this equals a over c, or in a bracket exponent b. All right, are you there? All right, so our equation becomes 6 over 4, or in a bracket exponent x, plus 9 over 4, or in a bracket exponent x equals 2. All right, so we are going to have 6 over 4, or in a bracket exponent x, plus 9 over 4, or in a bracket exponent x equals 2. All right, so 2 cancels itself 2. Sorry, 2 goes to 4 2 times, goes to 6 3. Okay. All right, so we're going to have 3 over 2, or in a bracket exponent x, plus 9 over 4, or in a bracket exponent x equals 2. All right, so this is what we have. Our equation becomes 3 over 2 exponent x, okay, plus 9 is the same as 3 squared, 4 is the same as 2 squared, or in a bracket exponent x equals 2. All right, so we're going to have 3 over 2, or in a bracket exponent x plus. Now let's apply the power of a quotient law of indices. We have already stated this law, okay? So we are going to have 3 over 2, or in a bracket squared, and then everything exponent x, okay? So we are applying the power of a quotient law of indices, okay? All right. All right, now let's apply, okay, the power of a power rule here, okay, of the power of a power rule of indices. Okay, so we are applying that concept here. All right, so our equation becomes 3 over 2, exponent x plus 3 over 2 exponent x, okay, all squared equals 2. All right, now at this point, you can see this term and this term are the same, okay? So you can say let 3 over 2 exponent x, okay, equals a. All right, so our equation becomes a exponent x plus a squared equals 2. So now we have a quadratic equation. So we are going to have a squared plus a, okay, plus a minus 2 equals 0. All right, now let's compare our equation to a squared plus bx plus c equals 0. So when we compare, we see a equals 1, b equals 1, and c equals minus 2. Now, let's use this to find out the determinant of the equation, okay? So we know the determinant is given as b squared minus 4ac, okay? So we are going to have determinant equals now 1 squared minus 4 times 1 times c, which is minus 2. So we are going to have determinant equals 1 plus 4, 2 is 8, okay? So you're going to have determinant equals 9, okay? Now, since the determinant is greater than 0, okay, and also a perfect square, okay, we can factorize, okay? Are you there? So since the determinant is greater than 0, and also a perfect square, we can factorize. Okay, so let's quote our equation again. Okay, so we have a squared plus a minus 2 equals 0. All right, so we're going to have a squared, okay, plus 2a minus 2 equals 0. So this is what we have. So our equation becomes a, so we are factorizing a plus 2 minus 1, a plus 2 equals 0. So we have a minus 1, a plus 2 equals 0. Okay, so let's call the first part equation 1, okay, and then let's call the second part equation 2. Okay, so we can say from equation 1, okay, a minus 1 equals 0. So a equals 0. So a1 equals 0. All right. Now, then we can say from equation 2, a plus 2 equals 0. So a equals minus 2, a2 equals minus 2. All right, now, we are getting negative here. Okay, now, but from our equation, okay, we are getting negative here. But from our equation, okay, we've stated that a equals 3 over 2 exponent x. Okay, now 3 over 2 is positive. Okay, and whenever you have a positive number raised to an exponent, it can never be negative. That is, okay, if a exponent n equals, okay, a exponent n is not equal to negative, okay, where a is positive. Okay, so a is not negative, okay, a exponent n is not negative in a situation where the base a is positive. Okay, therefore we can say 3 over 2 exponent x is not equal to minus 2. It's not equal to minus 2. All right. Now, the quadratic equation gave us two answers. And already we have disproved minus 2. So we are left with 0. Okay, so we say when a equals 0. Now, you cannot do this, okay, because if you do this, then it means you would have to apply logarithms at both sides, and log 0 is undefined, so we can't do that. So here we are going to use substitution to verify. So let's quote our question. So we're going to have 6 exponent x plus 9 exponent x equals 2 exponent 2x plus 1. So let's do the substitution. So we have 6 exponent 0 plus 9 exponent 0 equals 2 exponent 2 times 0 plus 1. Alright, so 6 exponent 0 is 1, 9 exponent 0 is 1, equals 2 exponent 0 is 1 plus 1. Okay, so, sorry, 2 times 0 is 0 plus 1. So we are going to have 2 equals 2. So that means x equals 0. Therefore, s equals 0 satisfies the equation.